All right, thank you, Douglas. So, welcome to class 20 and our last class. So, what today we're going to talk about primarily transactions, and we're gonna take any questions from error processing from last time after we're done with transactions, and that's it. So, um, let's actually Linda's not with us today, so it's just from my side it's just gonna be me. So let's get started by talking about transactions. So transactions essentially solve what I would call a classic accounting problem. So essentially, let's say that you owe somebody about $500, and you both use online banking, and you pay that person $500, but somebody pulls the plug on the machine while you're in the middle of payment. And so essentially what happened is
Mm-hmm.
five $500 got subtracted from your own account, but the other person did not get that $500. So the question is, where did it go?
Hmm? Evan,
Jignesh, Jignesh, I believe you need to put yourself on mute.
And Friday पहले तो मैंने ना पढ़ नाम तो जनरली रियानी मम्मी है.
Jignesh, you need to go on mute. I could hear you. Okay, good. Thank you. Thank you. All right. So, so transactions essentially try to solve that problem, and essentially it's something that has to do with mumps globals. And the idea is that if you take $500 from one person, you need to make sure that you add it to $500 of the other person right away. So we can let's start with a little routine to get to actually show you how that might work. Oh, wrong command. All right, so we're gonna start by setting the bank account, so to speak, for two people. So pretend I have a global called KBAN Bank that contains the actual what's the word I'm using? The actual amount of money that people have. So we're gonna say that I'll pick on Tom and Tony. So let's say that Tom has $1,000 in his bank account, and we're gonna pretend that Tony also has $1,000 in his bank account. So let's run this quote unquote transaction without making sure that everything executes. So we won't surround it by the transaction yet. So what I'm gonna show you is, so now All right.
All right.
All right, we're trying to make it simulated to be, hyper realistic. Ha ha ha. Well, let's see. Um, all right, and instead of typing 500, I'm gonna say set amount equal 500. And so we're gonna just say amount. And let's actually create a third account, which is the bank itself, and it starts out with 0. And we're going to say that actually we're going to say here we're going to do the bank commission. Of course, the bank has to take a piece out of everything. So out of the 500, so new commission, set commission equal to 0.05% times the amount, and set the amount equal to the amount minus the commission, because that got taken away. And so we're going to give the bank the commission, and we're going to give the rest of the amount goes to Tony. All right. And plus there's a break here whose purpose I will illustrate right now. So okay, so let's go ahead and save this. And it turns out I actually need to make another session, so I'm gonna go ahead and do that. And I'm trying to remember, how did I do it before? I think it's Control A, little c. No? Whatever that did was not good, so never mind. Just one sec, I forgot how to do it again. Here we go, window management. Create a new window, Control A, little c. Well, I was right. Why didn't it work? All right. Control A, C. Okay, it did work. So you guys don't have to move there yet. I'm just starting a MUMPS session over there. So, okay. So we're back. This is good. All right. So let's go ahead and print out our routine. Okay, so far so good. Does anybody have any questions about the routine? It should be pretty simple. So, any idea about the concepts? Any questions about the concepts here? All right. Think we're good. Anybody typing Skype? No. Okay. So I'm gonna run kband tran, and I'm gonna hit the brake, but let's pretend that this brake, actually what happened when we hit this brake is that somebody pulled out the power from the plug and the computer shut down. So we actually lost all the rest of this information. So if we go over to the other, let's jump over to the other screen. So type Control A like last time. All right, and let's look at our, what was our global? I forgot. Okay, Ben Bank. Yes, that's right, that's right. All righty. So what I want you to notice is that when the plug got pulled on the power, is that we took $500 away from Tom, and Tony has not gotten it yet. Now, Tony, you'd be mad, right? Tom Tom swears he paid you. That's right. Tom swears he paid you, but you do not see the money, and the bank says we use a state-of-the-art banking system based on cachet. We're gonna get that. We're gonna know why that's a joke on cachet in a moment. So it should be fun to understand the origin of the joke when we know why there's a little problem with cachet. So essentially here we pulled the plug and Tony didn't get his money, and that's a problem. I'm like, so the bank is looking, is like, Tom, you paid it, but Tony didn't get it. Why is that? All right. So I'm gonna type zgoto to blow away the stack, since we lost power and we don't have access to the program anymore. So we actually don't want this to happen. We don't want this to happen ever again. So the bank calls the MUMPS vendor and asks them, we have a problem here. We can't just, when the power gets pulled out, we can't just lose data. Oh yeah, sorry, we switched screens back. Thank you, Douglas. I forgot. So what we're gonna do is, the MUMPS vendor now tells us about the new commands we could use that came in the 1995 standard regarding transactions. So let's go ahead and try it. So the first command we need to learn is called TSTART, and we put a series of parentheses here, and I think we put a keyword called serial in here. And we're going to call the start of transaction. And at the end, to make sure that everything gets filed, we use a TCOMMIT, which is the end of a transaction. All right, let's go ahead and save this. Okay, let me just let me look in my quick MUMPS Pocket guide to make sure I type the syntax correctly. Because I could swear serial is either in quotes or not in quotes, and it's one of these. TSTART, TSTART, TSTART. Here's use, set, TSTART. Yeah, I think it's actually not in quotes. So let me try fixing that. Oh, okay, good. We're in business now. All right, I'm going to explain to you about all the little things inside of a transaction, but I just want to let you know that the tstart command happens to take a lot of a couple of arguments, which we're going to talk about in a moment. So here's tstart and tend. So let's see what happens this time. Okay, same problem. Now, I want you to notice that we actually set the initial values of everybody's bank account outside of a transaction, so that gets processed normally. Now we started the transaction, we broke, and let's pretend that we lost power. All right, so we lost everything. So let's switch back. Switch to the other screen, that is. Excuse me, guys. And let's look at our bank accounts. Now, I'm praying that everything here is working properly. Yoo-hoo! It does! Okay. All right. This time, when Tom was paying Tony, the power got lost in the middle, and as a result, but this time actually we were using MUMPS style transactions to say that if you do not reach the commit stage in the transaction, don't make any changes to the globals. And therefore, even though we lost power on the computer, neither Tom has not lost any of his money, and Tony did not get money that started from nothing, essentially. So, does anybody think this is cool or not, or just boring? So, I agree. It's really cool. I think it's really cool. However, very unfortunately, is the fact that does this work for a routine? Yes, Tom, it works for a routine. Um, the unfortunate part is transactions cannot combine with locks uh, inside of the transaction. I'll explain to you in a moment why, and I'll tell we were gonna make eventually a segue on why that doesn't it doesn't really work that well. Transactions don't work that well for us in Vista. So, all right. So um I'm just gonna check whether there are any transactions pending, and I use that using there's a variable called $T level. Oh, sorry guys, switch back. I keep forgetting. So there's a variable called $T level, which tells me if there is any transaction that's pending right now, and I don't have any, and I just wanted to confirm before I went back into the routine. No, let's just do an edit here. So, um, so the first thing I actually want to talk about is let's actually before that let's add one more command. So there is for our sake, usually when you're doing transactions, you might encounter an error in the middle and you have to restart the transaction. So we're actually gonna do that right now. So let's go ahead and delete this. Oh no, this one? Okay. And let's see if we can have a transaction that we can restart. So let's pretend that an error happens here. We need to start over. And for my example to work, I need to copy and paste. Oops! Yes, sorry. We need to put the amount outside of the transaction. So, nothing likes to work for me today. All right. New amount, set amount equal to 500. And we're just going to delete it from here. All right. And we have a counter. And so let's pretend an error happens here. And this is an error in our application. So let's pretend that that basically our database like FileMan tells us that I don't have something available and you need to try again. So what we could do is we're gonna simulate the error just by just checking that count is equal to 1, which is our original value. So if count is equal to 1, set count to equal to count plus 1, and then do restart the transaction. Alrighty, let's go ahead and print it, and we're gonna follow through it. All right, so we broke it at this break, so that's good to know. So let's see what happens. So here's the commission, that's what we're expecting. And then the next line is, then we get the amount. Oh, now why did it give me an error? We went to the error trap, so let me look at why. Oh, okay, amount minus com. Of course, I have the wrong variable. Okay, here we go. Let's just go ahead and fix it. It's COMM for commission. And let me make sure that I did not make this mistake again. Okay, good. All right, here's a commission. Amount minus commission. All right, let's see what happens. All right, did you guys see what just happened? let me do K-band tran plus 9. I want to show you. And K-band tran plus 10. So who wants to guess what happened? What did restart do? Exactly right, Tony. That's exactly what happened. It essentially, when we did restart, it made us abandon all our work that we have done, and discard it and go back to the start. So fabulous. This is actually how it's supposed to work. As you know, you have an error condition, you tell moms, oops, sorry, can you start again? And I'm like, okay, fine, I'll start again. And then it will take you back to the beginning. That's another what I call really cool feature in transactions. So that's good. But let's just make sure. Look at the amount. Is this right? Anybody? I know it's the last class, but you'll have to pretend to care for my sake. That's correct. It's the wrong amount. So how come we have the wrong amount? If we scroll back a bit, you'll notice that we calculated a commission. Then we subtracted the commission from the amount, and therefore that's the wrong amount. So we're gonna have to fix it. And again, MUMPS has a feature for that. And let's go ahead and fix that and try to fix it. So all right. So let's put amount in parentheses after the TSTART. And I'm gonna explain to you what this does. Actually, it's gonna be pretty visible to you. So we're gonna do the same thing again. Ah, yes, yes, yes. Oh, come on. That's the VPE which we need to fix. So no. Set error trap to equal to break. All right, fantastic. All righty, we hit our break. Here is our commission. And then we subtract the amount from our commission. Now, our count is, we're actually going to restart over here. Let's write the amount. Okay, 475. Nobody disagrees that this is what the amount is right now. Let's go here. Now, if you remember the line that we just ran before this, it's actually MUMPS, GTM ran it invisibly, but, oh, oopsie guys, it did not save the routine. Okay, no problem. Let's back up. So Z go to, so let me make sure I Z-link it and write $text of kband tran plus 9 upcart kband tran. Make sure, yes, now it's correct. Alrighty, here's our break. And let's write the amount. All right, we go back up here again when we did a restart, and let's write $text of K-band tran plus 9, and you could see that this is the correct line. Let's see what our amount is. All right, do you see that? So what just happened was we told GTM that in the transaction, it has to reset variables to their original values if the transaction restarts. And this is exactly what just happened here. So let's continue. And this is not going to happen again because we're already after we went after this. We already have count greater than 1. And here's Tony. And now we actually file the transaction and we're done. And if we look at our data, K-band bank, you could see that the bank has $25 in commission. Tom paid $500 and Tony got $475. Okay, so let's try to sort of summarize the commands that we need to know. So let's take a look at the whole routine again, so that we can understand the commands that you need to understand, that we need to know for knowing how transactions to work. So transactions have 3 commands. Have TSTART, TCOMMIT. Now these are the two the ones that start a transaction, start and commit a transaction. And the other one that we have to know is restart, which restarts a transaction. And I'm gonna write the next sentence in capitals because it's really important. The MUMPS implementation is free to restart transactions on its own if it finds that the database region is being accessed by other processes and it cannot guarantee, I could never spell that word, guarantee that the transaction will be filed correctly. So here's the important point that you need to understand from this. Even though you might not put a restart in your transaction, MUMPS might just decide to restart it for you because it says, oh my God, too many people are accessing these things at the same time. I cannot file the data and guarantee that it will be all filed correctly. Therefore, I'm going to have to try again. And that actually happens a lot with GTM. Again, notice I'm not talking about cache, and I'll tell you why in a moment. So the abbreviations for the commands are TS, TC, and TRE. there's one variable that may be useful, especially in error processing, and that is $T level, which says whether you are in a transaction or not. Okay, and let's see what other transaction commands there are. Nope, that's it. That's all of them. You can put tcommit, tstart, tcommit inside other tstart, tcommits. So you could have sub-transactions inside of the main transaction, but only the first one really counts to mumps. So essentially, if the first one doesn't complete, your children do not complete. And every time you add a little transaction, your $T level is going to be incremented by 1. So T level starts off at 0 when there's no transaction. Then it becomes 1 when you do your first transaction, then 2 and 3 and 4 and so forth. All right, let's see. So these are all the transaction commands, and all of them are really easy to use except the tstart one. So let's talk about tstart some more. If you remember, let me write the syntax, and I can't remember what the line was. Was it? It was the write $text of +9 of caret k band tran. Nope. Too early. 10. Okay, here we go. All right, so TSTART has several formats. So says start a transaction, cause an error if you restart. All right. Now, why does it cause an error to when you restart? Well, this brings us because the parens are necessary for a restart. All right. So far, so good. So I said parens are necessary for a restart. What the hell are parens necessary for a restart? Let's figure out why we need parens. So tstart with parens means start a transaction, and if you restart, restore the variables inside the parentheses when you restart. Otherwise, you do not know what to do with the variables modified inside the transaction. And this is actually defined inside the MUMPS standard, inside the MUMPS 95 standard. So nobody's actually, GTM did not make this up. These are actually the rules. So let me show you the various formats that you could do with parentheses. So you could do TSTART. This means don't restore any variables with restart. You could do this, which means restore var1 and var2 on restart. And then you could do the following. You could just put a star, which means restore all variables on restart. So that takes care of the parentheses. So let's talk about the what comes after the parentheses, which is the colon and then the transaction keywords. So TSTART, I cannot type today. Start colon and we use serial in our program. So what this means is that make sure only one person actually not person, process does the transaction at a time. So essentially, this is you always have the problems when people are trying to access the records all together and who gets it first. Well, serial essentially says you don't have to do any don't worry about locks. I'll take care of blocking other people, and I will I'll block any other person who wants to access the transaction while it's already running. It has to finish so that the other person could actually run it. The other one that's we are not going to use because it's not that useful is called. Oh, by the way, we said I made a mistake here. It's serial, no quotes. I made that mistake before. The other one is called transaction ID equals and an ID number that you assign. Now, last one, as far as I know, is useless because I've never figured out if it's any use, and I'm pretty sure I've been over the GTM documentation several times on this, and I've never seen that they actually made it of any use. So far so good. This is basically how we use transaction in MUMPS. And here's the routine again, so you could get it back in your head. Okay. So let's go back. Let's go back a little bit and figure out. This is great. This is fabulous, actually. How come VISTA has no transactions whatsoever? So this actually leads us back to a couple of problems with transactions. We have, and here I'm going to mention it, we have the cache problem. Cache doesn't implement restarting of transactions. So it effectively means that cache doesn't implement true transactions because a restart is a restart argument on TSTART is required, which is these are the parens. So we have this big problem that essentially that cache does not implement them correctly, and essentially they're essentially a no-op on cache, and that's a problem. Believe it or not, you would think that the company behind cache would actually put more of their money into making sure that transactions work correctly, given how important they are, but apparently not. So that's one problem. Our other problem why we don't use them in Vista is that transactions cannot work. Oh, well, let's just call it the lock problem. Transactions don't work well with locks inside of transactions. So why is a lock inside of a transaction a problem? Oh, sorry. Lost sound. Anybody else? Do you guys have it? Okay, no. Okay, good. Tom, are you okay now? Do you still hear me? Do you hear me, or are you still gone? Let me type it. Okay, Tom. The others could hear me. So do you wanna drop off and dial back in? Would that help? Oh, sorry, he can't hear me. What am I thinking? Do you? Oh, okay. All right. While Tom is trying to reconnect, I'm just gonna resume. There's not. Well, no. I'll wait for him. Never mind. Just want to see. Hmm. All right. Well, Tom, I'm gonna drop you off, and let's see if you could join. Oh, back on. All right. Let me just try this quickly. If it doesn't work, then we can just do end call with this person. And all right, and I invited them back. All right, let's see. He's still trying to pick up. All right, well, I suppose we're gonna move on now since looks like it's a network problem on his end. So the lock problem inside of transactions. So transactions are all about hiding global activity inside of them. locks 1 cause a violation of the hiding since they are visible to other processes, and more importantly is introduce major delays to transactions, making it difficult to acquire a database region to file data. So on the atomic level below the mumps layer, uh, on disk, mumps has to acquire when it's doing a transaction and it has to commit everything. It actually has to lock those database regions and it has to file everything all together. Well, you know that locks usually have timeouts on them, and it has to look for other processes, and it's very against transactions because of all of those delays. It makes transactions very difficult to actually complete. So the upshot of this is, since Vista uses locks all over the place, you can't introduce transactions without making sure that no locks are done inside of a transaction. So this is only practical for new infrastructure packages, because all the other packages use them, and the infrastructure stuff contain the locks. So this is the sad part about transactions. They are extremely valuable, but we actually have to do a big major redesign of Vista in order to be able to use them. So let me think. Is there anything else that I want to tell you about transactions? Well, I guess my only advice is a conclusion for transactions, and that is, transactions are okay as long as, one, you plan to only run on GTM, and two, you are doing it over either your own package or an infrastructure package in Vista. So if you're modifying the kernel or Taskman and you own that package, Taskman or FileMan, and you own the package and you know what you're doing, you definitely could use transactions. But otherwise, you have these two major problems: the cache problem and the lock problem. So, all right. So how can we make sure if a patient is not registered successfully in Vista, roll back and register again? You actually do not have that option. You're going to have to imitate a rollback. So to imitate a rollback, you can just you can delete the data and try to file it again. So that's what you're going to have to do. So that was a question from Manoj, by the way, if those didn't see it. So how can we make sure if a patient is not registered successfully in VISTA, roll back and register again. So, and Manoj, the other thing to understand is that FileMan is very particular on how it works. There is no, the FileMan will always say, yes, I succeeded, or no, I did not succeed when you use the new database server APIs. It will not give you an intermediate state. It will tell you, yes, I was able to file this data, and here is the internal entry number. So when we say that something did not happen successfully in VISTA, you know, that's possible, but it's the semantic context needs to be better defined. It's not possible with the new FileMan DBS APIs. Okay, let's see. I'm trying to think. I guess that's it for transactions. Does anybody have any questions about transactions? Okay, no questions. I love that. I really love that. Okay. My next thing is, does anybody have any questions from last week's class? And I'm sorry I did not get you the notes. I will get you the notes today because it looks like they were locked in here, so the session is still here. Okay, well, if this is the case, then here is here is to us for finishing 20 classes. It has been really a long time actually, and I'm glad it's over now. And the other thing is that those of you who are actually planning to finish the semester homework or the semester assignment, I originally said January 30th, but if you want to extend that by 1 week, you certainly can. And I would certainly like, if you send it to me, I'll be able to happily critique it and take a look at it. So, and with this, if nobody has any more questions, we can end our class. Okay. Let's see. All righty, everybody. Thank you all, and I hope you enjoyed the class. And you could certainly like you to keep in touch.